Good day, everyone. Today we'll be presenting a comprehensive analysis of BYD Auto Company Limited, one of the fastest growing electric vehicle manufacturers in the world. This analysis explores the company's global expansion efforts, the operational challenges it faces in international markets, and strategic alternatives to enhance its global competitiveness. Our team, composed of John Mark Lorconsea, Maria Micaela Kyle Dayao, Daniela Eleanor Estacio, and Mary Joyce Manalo, has examined BYD's performance through a system and decision analysis. So we'll walk through our findings, including the root causes of their challenges, evaluated alternatives, and our final recommendation for sustaining long term success in a rapidly evolving global market. BYD has expanded rapidly into international market, but its quality assurance and after-sales system haven't kept up. Most decisions are still made in China, which limits responsiveness abroad. Communication with overseas service centers is slow, parts are delayed, and product issues go unresolved for too long. These weaknesses hurt customer satisfaction and damage BYD's reputation, making it harder to compete in mature markets. So we propose alternative one or the regional hubs with integrated quality assurance and after sales team. This alternative proposes decentralized regional hubs in markets like Brazil, Hungary, and Thailand. These would have their own assembly lines, quality assurance labs, and spare parts depot. Delegating non-core parts production to regional suppliers eases pressure on BYD's central supply chain. Local after-sales team would operate independently, improving responsiveness and customer satisfaction. Regional hubs offer major benefits. First is they streamline logistics, local production cuts delay and cost. Second, on-site quality assurance means defects are caught earlier. Third, local teams can adapt services to meet regional needs. And finally, distributing operations improves resilience against disruptions like natural disasters or geopolitical risk. However, this model comes with trade offs. Building hubs require large investments in land, facilities, and staffing. It also increases operational complexity, with multiple sites needing consistent quality and reporting. And finding and training skilled local talents adds another layer of difficulty. The next alternative that we propose is integrated network for real-time monitoring. Alternative 2 is a tech-driven solution. It builds a centralized digital system linking production, research and development, quality assurance, and after-sales. Using artificial intelligence, ERP, and virtual models, it enables real-time quality tracking, predictive maintenance, and smarter logistics. Service centers worldwide can share data directly with engineers, speeding up problem solving and product improvements. This system offers strong advantages. It's highly scalable and flexible, ideal for entering new markets without building new factories. Real time data supports better decision making. AI improves efficiency and reduces costs by predicting issues before they happen, and resulting in fewer calls and better customer experiences. Still, there are major challenges. Developing the system requires high upfront investment in software, hardware, and skilled IT staff. Implementation is complex. It involves cleaning and integrating data from various outdated systems. Finally, putting everything on one platform increases cybersecurity risk, so strong protections are essential. To better understand the root of BYD's global service issues, we apply the 5 whys method. The service problem is unmet service standards abroad. Tracing it back, we see that quality assurance and after sales systems haven't scaled with production. That's because key function remains centralized in China, a strategy focused on rapid production rather than global support. Ultimately, the company prioritized speed over regional adaptability. The core issue is a mismatch between production growth and the development of support systems. While BYD's vehicle output has surged, logistics, quality control, and service infrastructures haven't kept pace. This causes three major problems. First is overproduction has led to unsolved inventory, 3.221 months of supply versus an industry average of 1.38 second. Um, Second is customer feedback. It is slow to reach engineering teams, causing delays in fixing defects. And lastly, is weak global support systems have left customers in places like Australia and Thailand waiting for months for service. These challenges are eroding customer trust and harming BYD's global reputation. To solve these, BYD must realign its core production with responsiveness, scalable support systems. So these objectives must include cutting international service turnaround time by 50%, creating real-time feedback loops, scaling quality assurance with production, and improving customer satisfaction by at least 20%. The one objectives are minimizing added costs, strengthening brand loyalty, building flexibility, and maintaining the advantages of vertical integration. Let's now compare both alternatives. So, alternative one involves building regional hubs with their own quality assurance and service team. This model suits Europe, ASEAN countries, and Latin America. Alternative 2 uses BYD's existing structure to roll out centralized digital feedback system powered by AI and virtual modeling. The pros and cons of alternative 1. So the pros is it cuts service delays, improves local responsiveness, and spreads risk. Next is the cons. So high capital costs, slower to scale, and need strong local talents. So the pros for Alternative 2 is scalable without building new sites, proactive quality control, and cost effective in the long run. While the cons of Alternative 2 is complex IT integration and higher cybersecurity risk. Here's a side-by-side comparison across key decision area. First is service turnaround time. Alternative 1 offers strong local improvement. Alternative 2 achieves this through automation. So for cost, Alternative 1 has a higher physical setup cost, and Alternative 2 needs heavy software and IT investment. Next is scalability. Alternative 2 is faster and more flexible, and Alternative 1 is slower due to infrastructure demands. So for the criteria quality control, alternative one uses hands-on quality assurance. Alternative two uses artificial intelligence for proactive management. So for risk management, alternative one spreads risk geographically, and alternative two centralizes risk in the system. So for implementation, alternative one requires land and training, and alternative two demands strong IT infrastructure.
Cost benefit analysis or criteria analysis, as Alternative 1 offers a strong local quality control but also requires a high capital for land, infrastructure, and staff, making it less practical for short term. Its low escapability and complex coordination also limits its effectiveness as BYD grows. Meanwhile, Alternative 2, though requiring upfront investment and facing cybersecurity risks, it delivers faster scalability, automation, and centralized data use as it directly addresses the BYD service and quality issues through a real-time monitoring and predictive analytics. Therefore, Alternative 2 is the suitable option for BYD's global strategy as it combines the innovation, responsiveness, and cost efficiency that enables their quickly issues to resolve and reduce turnaround time and improve collaboration that supports the international expansion without a major physical infrastructure. To objectively evaluate each alternative, six key criteria were identified, each assigned a specific weight based on its relevance to BYD's operational goals. Each alternative was then scored on a scale of 1 to 5 as these scores were then multiplied by criterions weight to determine a weight score had been identified the most suitable option. First, we have the service turnaround time with 25% of weight. This criterion carries the highest weight as fast and reliable service is essential for customer satisfaction and protecting BYD's brand image. Next is the scalability with 20% of weight. Scalability is vital as BYD expands globally. Next is the cost of 20% weight. Cost considers both initial and long-term financial sustainability, yet affordable and effective solutions were rated higher, especially for those that offers a high value relative to investment. Next is the automation level. Automation ensures the consistency, reduces the manual workload, and speeds up the operation. Next is the data integration and feedback. The ability to feed a real-time data back to R&D for continuous improvement is important for solution enabling this integration earn the higher scores. And lastly is the implementation complexity. Lower complexity translates to a fewer deployment risks and faster implementation, where alternatives that are easier to roll out receive strong scores. To ensure a clear and consistent evaluation for each alternative, a standardized performance rating was used. This scale helps assess how well options meets the identified criteria. The score of 5 is it means that it is highly effective. The alternative fully meets or exceeds the expectation in this area. The score of 4 is effective, as the alternative meets the requirements with only minor limitations. The score of 3 is moderately effective, as the alternative provides an average or acceptable level of performance. The score of 2 is less effective, as the alternative shows the weakness and only partially meets the requirements. And lastly, the score of 1 is ineffective. The alternative fails to meet expectation and performs poorly in this area. Using the previously defined criteria and performance rating scale, each alternative was evaluated and assigned a weighted score. As this structured approach allows us to identify which options is better to support BYD strategic goals. So first, the service turnaround time. The alternative one score of 4 as it provides effective local resolution but relies on manual process. Its weight score is 1, while the alternative 2 scored 5, offering a real-time prediction and faster response, earning a weight score of 1.25. Next, scalability of 20%. Alternative 1 scores 2, since its expansion is low and heavily dependent on physical infrastructure, and also weighted score to 0.4. Next is the alternative 2 scored 5 as it digitally replicable across multiple markets as it weight score of 1, 1.00. Next is the cost of 20%. Alternative 1 scored of 2 due to high upfront investment in land, infrastructure, and staff, weighting a score of 0.40. And the alternative 2 scored of 3. While still costly, it requires less capital than physical hubs, weighted score of 0.60. The fourth one is automation level of 15%. Alternative 1 scored 2, relying on mostly manual quality checks, weighting score of 0.30. While the alternative 2 scored of 5, integrating predictive system and AI, weighted scores of 0.75. And the fifth is data integration and feedback with 10%. Alternative 1 scored 3 with semi-effective with data sharing weight score of 0.30. And next is the alternative 2 scored of 5 enabling distance to global visibility and automated feedback weight score of 0.50. The sixth is the implementation of complexity. Both alternatives scored 3. Alternative 1 involves a physical setup and hiring, while alternative 2 has a complex digital integration. Both receive a weight score of 0.30. The final scores of alternative 1 is 2.70, while the alternative 2 is 4.40. The evaluation revealed that Alternative 2 integrated network for real-time quality monitoring and service feedback outperformed Alternative 1 with the score of 4.40 versus the 2.70. While both options show a potential, Alternative 2 stood out in key areas such as digital capabilities and ability to deliver consistent, predictive service across regions. In contrast, Alternative 2 is simpler to implement and but was limited by highly cost, low automation, and poor scalability. Given to BYD's needs for a scalable, data-driven service model, Alternative 2 is deemed the most suitable option. The best alternative, after the evaluation using weight criteria and performance scoring, the best alternative for BYDs is Alternative 2, integrated network for real-time quality monitoring and service feedback. The rationale for selection, first we have superior service efficiency as Alternative 2 improves turnaround time by enabling immediate uh, issues resolution through a real-time monitoring and feedback. Second is the real-time integration and proactive service. It uses the predictive analytics and integrated data to address problems before these escalate, enhancing the customer's satisfaction. Third is cost effectiveness over time. Despite the higher initial cost, it reduces a long-term expense through a lower labor needs, fewer errors, and improved efficiency. Fourth is the advanced automation and quality control. As automated system and AI diagnostic ensures the consistent, high quality service across all areas. Fifth is the global adaptability, as its digital scalability allows for a unified global service model with localized data-driven responses. Consideration for future growth, as Alternative 2 currently meets the BYD's needs with automation, real-time integration, and improved service, as future global expansion may challenge the system's ability to manage larger data volumes and multilingual needs. Next is the advanced AI integration will be essential as service demands grows and continuous investment in infrastructure, cybersecurity, and emerging tech is necessary for BYD's growth. And personalization and predictive diagnostics should be prioritized to maintain a long-term competitiveness.
For the systems design solution, we could make an Ishikawa diagram to further analyze the problem. Under people, there's limited analysis. Under methods, there's insufficient reporting procedures. For measurement, it's delayed defect detection. For environment, we have one of it is outdated sensors, and machine is an unreliable system. To modernize BYD system service or service system, we propose a fully integrated digital network that links service data, R&D, and production through AI analytics and ERP systems. Using a model, every customer complaint becomes an actionable data point, as automatically tracked, analyzed, and transmitted for faster resolution. Value stream map shows a dramatic improvement in the turnaround time and traceability. What once took months can now be handled in days thanks to digital defect reporting, real-time R&D syncing, and predictive alerts that prevent future issues. Like an industrial control loop, the system receives service input process it through an AI controller and generates immediate countermeasures. KPIs are tracked in real time to ensure high quality, first pass fixes and a measurable boost in customer satisfaction.
The next part of this presentation will talk about the strategic plan for implementing the integrated digital network at BYD. This initiative is designed to transform how we manage global service quality and customer satisfaction through digital innovation. Over the next several minutes, I will walk you through our objectives, key activities, required resources, timeline, roles, and success measures, as well as risk management. This project represents a critical step forward in our commitment to operational excellence and customer centricity worldwide. The primary objective is to successfully implement an integrated digital network that delivers measurable improvements across several critical areas. Firstly, we aim to reduce service turnaround time by at least 50% globally, which means customers will experience faster resolutions to their issues. Secondly, this system will improve global customer satisfaction by at least 20% by enabling more responsive and transparent service. Third, the network will provide real-time quality monitoring, allowing the R&D and quality teams to detect and address defects faster than ever before. Together, these goals will not only strengthen BYD's market reputation but also enhance operational efficiency and competitive advantage. To realize these objectives, we have outlined a set of critical activities. The first is procurement and development of an ERP system enhanced with AI and digital twin technologies. This forms the backbone of our data integration and predictive analytics capabilities. Next, we will digitize legacy service and quality assurance records, ensuring historical data is accessible and actionable in the new system. We will conduct comprehensive training for personnel at all regional offices to ensure smooth adoption and effective system use. Cybersecurity is a top priority, so we'll implement robust security protocols to safeguard sensitive information. Finally, we will launch a pilot program in three high priority markets: Australia, Brazil, and Hungary, to validate system functionality and gather user feedback before full deployment. Successful implementation depends on securing the right resources. Technically, we require advanced IT infrastructure including high-capacity servers, cloud computing platforms, and AI modules to support data processing and analytics. We also need ERP and digital twin software licenses or custom development. Our human resources plan includes hiring or contracting data engineers, cybersecurity experts, and training personnel who will lead system deployment and education. Additionally, a change management support team will provide critical assistance to address resistance and facilitate smooth transitions across diverse regional teams. Budget allocation will cover software, hardware, staffing, and training costs. For the timeline, they will be divided into four structured phases over approximately 12 months and beyond. In phase one, which are the first 3 months, we will be completing the system design, selecting our vendors, and preparing the infrastructure required. Phase two, which is the 3 months to six, focuses on data integration and running pilot tests in selected markets to identify issues and optimize performance. In phase three, which are months 6 to 12, we will conduct the full global rollout, including comprehensive training for all regional service centers. Lastly, phase four, which is after 1 year, emphasizes continuous improvements and system scaling to incorporate new features and expand the network's reach. This phased approach balances speed with careful validation. Clear accountability is vital to success. The CTO, or the Chief Technology Officer, will provide overall leadership and strategic direction. The Global IT Vision division will manage the technical aspects of system rollout and integration. Our R&D and quality divisions will play an active role by integrating real-time feedback into product improvements. Regional service centers will support data entry and ensure frontline teams are trained and empowered. Lastly, the cybersecurity team will be responsible for establishing and maintaining the security framework, protecting data confidentiality, and preventing breaches. These will all be measured through clear, quantifiable factors or indicators. Firstly, our goal is to reduce the global service turnaround by at least 50%, as stated, reflecting faster customer issue resolution. Second, all defect reports have to be successfully received by the R&D within 24 hours, enabling rapid root cause analysis. Third, it is vital to target a 20% increase in international customer satisfaction, gauged through surveys and feedback channels. Lastly, we aim for 100% integration of all service centers into the digital network, ensuring no region is left behind. These metrics will be tracked continuously and reported regularly. Of course, implementing a project of this scale naturally involves risks. One key risk is data migration delays, which could disrupt service continuity. To mitigate this, we'll use agile rollout methods and sandbox environments for testing data transfer before live implementation. Cybersecurity is another critical concern. Breaches could compromise sensitive customer and product data. To prevent this, we will be deploying layered encryption techniques and conduct regular security audits. Additionally, user resistance to new systems is a common challenge. This will be addressed by delivering early and ongoing training, collecting user feedback, and refining the system based on real world usage to improve adoption. Continuous monitoring is a key project to success. A dedicated PMO or a project management office will conduct monthly reviews of the project's progress against milestones, analyze defect report cycle systems, and monitor customer feedback trends. System stability metrics will also be tracked to ensure performance meets expectations. This structured approach enables us to identify and resolve issues proactively, make data driven adjustments, and keep stakeholders informed throughout the implementation journey. Adopting the integrated digital network represents a strategic leap for BYD, moving beyond a simple technology upgrade to a future-ready, scalable, and intelligent system that enhances responsiveness, reduces service turnaround times, and strengthens quality feedback loops. This approach allows BYD to meet growing international market demands efficiently and cost-effectively, maintaining its competitive advantage without the heavy investment required for physical regional hubs. With committed implementation and continuous innovation, BYD is poised to overcome current operational challenges and establish itself as a truly global, customer-centric automotive leader.